Any country in America's Black Book is currently not safe. They have just unleashed a monster bomber so advanced it can strike anywhere on Earth without being detected. This invisible giant costs more than some countries' entire military budgets and carries enough firepower to level entire cities. Is America's new Sky Titan really ahead of Russia's hypersonic threats and China's secret stealth projects? What will happen when these aerial giants finally clash? Join us as we get all the details on the United States' $4 billion bomber. In the Nevada desert, America's most expensive military secret takes flight. The B-21 Raider represents more than advanced engineering. It embodies the future of strategic warfare wrapped in technology so classified that even its basic specifications remain partially hidden from public view. Northrop Grumman secured this contract in 2015 after beating Boeing in one of the most competitive defense competitions in modern history. The stakes were enormous. Replace both the aging B-2 Spirit and the supersonic B-1 Lancer with a single next-generation platform. The Air Force demanded something unprecedented, a bomber that could penetrate the most sophisticated air defenses while carrying both conventional and nuclear weapons across intercontinental distances. The Raider's stealth capabilities push beyond anything previously achieved in military aviation. While the B-2 Spirit broke new ground in radar evasion, the B-21 incorporates decades of additional research into what engineers call signature management. Its angular surfaces aren't just designed to deflect radar waves, they actively absorb and scatter electromagnetic energy across multiple spectrums. The aircraft's skin contains advanced materials that make traditional radar systems struggle to maintain target locks. This invisibility comes at a staggering price. Each B-21 costs $639 million to build, but the program's total development expenses push the real investment far higher. When research, testing, and infrastructure costs factor in, America's commitment to this flying ghost approaches $4 billion. That figure represents more than the entire defense budgets of most nations. The B-2 Spirit established the template for this astronomical spending pattern. Only 21 B-2 bombers ever entered service, making each aircraft worth over $1 billion when maintenance and operational costs accumulate over their lifespans. At $737 million per unit in flyaway costs alone, the Spirit earned its title as history's most expensive bomber. Yet the Spirit's unique capabilities justified its price tag. No other aircraft can transport heavy air-to-surface standoff weapons while maintaining complete stealth configuration. Traditional bombers sacrifice invisibility when they carry external missiles or bombs. The B-2's internal weapons bays solve this problem by keeping ordnance hidden within the aircraft's radar-absorbing shell. The B-21 takes this concept further by incorporating both manned and unmanned operational modes. Pilots can fly traditional missions or activate autonomous systems that execute predetermined strikes without human intervention. This dual capability transforms the bomber from a crude weapons platform into a remotely operated strategic asset. Both aircraft share the flying wing design that maximizes stealth while providing exceptional range. The B-2's triangular silhouette became iconic during its introduction in 1997, 8 years after its maiden flight. The B-21 refines this shape with smoother curves and updated materials that enhance both aerodynamics and electromagnetic invisibility. The Air Force plans to field at least 100 B-21 Raiders within the next decade. This fleet will work alongside the venerable B-52 Stratofortress, creating a two-tier bomber force that combines stealth penetration with massive payload delivery. The B-52's 69 years of continuous service prove that well-designed aircraft can remain relevant across multiple generations of warfare. The Raider's subsonic speed might seem limiting compared to supersonic alternatives, but stealth technology prioritizes invisibility over raw velocity. Enemy air defenses cannot engage targets they cannot detect. The B-21's ability to approach high-value targets unobserved provides tactical advantages that outweigh pure speed. Advanced radar-absorbent coatings cover every surface of both bombers. These materials require constant maintenance in specialized facilities, contributing significantly to operational expenses. The B-2's maintenance demands consumed enormous resources throughout its service life. lessons that influence the B-21's more practical design approach. America's investment in these invisible titans reflects a fundamental shift in strategic thinking. Traditional bombers relied on altitude, speed, or defensive armament to survive hostile airspace. Modern stealth bombers depend entirely on remaining undetected until their weapons reach their targets. This philosophy demands perfection in design execution and manufacturing precision that pushes current technology to its absolute limits. The B-21 Raider represents the culmination of this stealth-first approach, combining lessons learned from the B-2 Spirit with advances in materials science, computer processing, and autonomous systems. When these invisible giants begin regular operations in the mid-20s, they will define air power for the next 50 years. But what shields America while these future ghosts remain in testing? 3 battle-tested giants continue protecting American skies, each representing decades of proven dominance in strategic warfare. These legendary bombers didn't just survive the test of time, they defined it. The Boeing B-52 Stratofortress stands as aviation's most remarkable success story. 69 years after its first flight, this 8-engine giant receives constant upgrades that keep it more relevant today than when it first thundered across Cold War skies. Boeing engineers continue developing new systems for an aircraft that predates most of its current pilots by several decades. 76 of these strategic bombers currently serve the Air Force, each representing a $313 million investment in proven capability. The Stratofortress carries 70,000 pounds of weapons across 8,800 miles without refueling, specifications that remain impressive by modern standards. 744 B-52s rolled off production lines during the aircraft's manufacturing run, creating a bomber fleet that served through Vietnam, the Gulf War, Afghanistan, and countless other conflicts. The B-52's longevity stems from its fundamental design excellence and adaptability to changing mission requirements. What began as a nuclear deterrent evolved into a precision strike platform capable of launching cruise missiles, dropping conventional bombs, and conducting intelligence-gathering missions. Current upgrade programs will extend the Stratofortress service life well into the 2040s, making it potentially the first military aircraft to serve for nearly a century. While the B-52 represents endurance, the Rockwell B-1 Lancer embodies raw power and speed. This $317 million supersonic bomber emerged from intense competition to create an aircraft combining the Mach 2 speeds of earlier designs with the massive payload capacity that modern warfare demands. The result earned the nickname Bone, a playful reference to its B-1 designation that reflects the aircraft's fearsome reputation. The B-1 stands alone among active strategic bombers as the only supersonic platform in current service. Its variable sweep wings adjust automatically during flight, providing efficient cruise performance and high-speed penetration capabilities that fixed-wing designs cannot match. Internal weapons bays accommodate 75,000 pounds of ordnance while maintaining the aircraft's aerodynamic efficiency at all speeds. 24 missiles can fit within the Lancer's capacious bomb bays, transforming the aircraft into a long-range arsenal ship capable of overwhelming enemy defenses through sheer volume of fire. This approach contrasts sharply with stealth bombers that rely on invisibility rather than overwhelming firepower to accomplish their missions. The B-2 Spirit bridges these philosophies by combining moderate payload capacity with revolutionary stealth technology. 21 of these triangular bombers cost taxpayers over $1 billion each when development and operational expenses accumulate over their service lives. This astronomical price reflects the Spirit's unique ability to penetrate sophisticated air defense networks while carrying nuclear or conventional weapons to targets anywhere on Earth. Each B-2 can deploy 8 500-pound GPS-guided bombs or 16 nuclear warheads, depending on mission requirements. The aircraft's internal weapons bays maintain stealth characteristics that external pylons would compromise, ensuring the bomber remains invisible to enemy radar throughout its approach and attack phases. These 3 platforms create a layered deterrent capability that adapts to different threat environments and mission profiles. The B-52 provides massive firepower for situations where air superiority already exists. The B-1 offers rapid response and overwhelming offensive capability when speed matters more than stealth. The B-2 delivers precision strikes against the most heavily defended targets when invisibility becomes essential for mission success. Current modernization programs ensure all three bombers will serve alongside the incoming B-21 Raiders, creating America's most diverse and capable strategic bomber fleet in history. This four-aircraft lineup combines proven reliability with cutting-edge technology, maintaining American air power supremacy across multiple domains of conflict. The success of these veteran platforms validates the substantial investment now flowing into next generation of stealth technology, proving that superior bombers remain aviation's ultimate expression of national power. But America's bomber dominance faces formidable challenges from the east. Russia operates the world's most diverse strategic bomber fleet, combining Cold War engineering with modern upgrades that keep these aging giants competitive against Western technology. Moscow's aerial arsenal proves that raw power and clever modernization can rival even the most advanced stealth systems. The Tupolev Tu-95 remains aviation's most unusual strategic bomber. This massive aircraft generates its thunderous power through four turboprop engines driving contra-rotating propellers, making it the only propeller-driven strategic bomber still patrolling global skies. NATO designated this distinctive giant Bear, a nickname that perfectly captures its imposing presence and enduring strength. First flying in 1952, the Tu-95 predates America's B-52 by mere months, yet both aircraft continue serving their respective nations with remarkable effectiveness. The Bear's four Kuznetsov engines produce enough thrust to carry 415,000 pounds of weapons across intercontinental distances, a payload capacity that dwarfs most modern bombers. Russian engineers designed this aircraft for nuclear deterrence missions that require massive range and devastating firepower rather than speed or stealth. The Tu-95 propeller configuration creates a unique acoustic signature that Western submarine crews learned to identify during decades of Cold War patrols. These distinctive engines generate incredible fuel efficiency, allowing the Bear to conduct missions lasting over 15 hours without aerial refueling. Current modernization programs extend the aircraft's service life until the 2040s, matching the B-52's remarkable longevity. At the opposite end of the speed spectrum, the Tupolev Tu-160 represents Russia's commitment to supersonic strategic bombing. NATO calls this swept-wing giant Blackjack, acknowledging its status as the world's largest and heaviest bomber, capable of Mach 2 flight. The Tu-160 holds multiple aviation records that American bombers cannot match, including fastest operational bomber and heaviest variable sweep-wing aircraft ever built. This white-painted Leviathan stretches longer than a football field and weighs over 270 tons when fully loaded. Two massive internal weapons bays accommodate up to 45 tons of conventional or nuclear ordnance, while the aircraft's supersonic capability allows rapid penetration of enemy airspace before defensive systems can respond effectively. Each Tu-160 costs $103 million to build, making it surprisingly affordable compared to Western equivalents. The Blackjack's variable sweep wings automatically adjust during flight to optimize performance across different speed regimes. Swept forward, they provide efficient cruise performance during long-range missions. Swept back, they enable the aircraft to achieve supersonic speeds that few strategic bombers can sustain. This mechanical complexity requires extensive maintenance, but delivers unmatched versatility in operational employment. Russia continues producing updated Tu-160 variants, incorporating modern navigation systems, improved defensive countermeasures, and enhanced weapons delivery capabilities. Recent variants carry advanced cruise missiles that extend the bomber's effective range far beyond its already impressive specifications. These standoff weapons allow the Blackjack to strike targets without entering heavily defended airspace. The Tu-22M fills the gap between these extremes, providing medium-range supersonic capability for regional missions. NATO's backfire designation reflects this aircraft's role as a tactical bomber optimized for theater operations, rather than intercontinental strikes. 497 of these versatile bombers entered service before production ended in 1997. The backfire carries 24,000 kilograms of weapons at speeds exceeding 560 miles per hour, making it an effective platform for both conventional and nuclear missions. Recent conflicts demonstrated the Tu-22M's continued relevance in modern warfare, where its combination of speed, payload, and moderate operating costs provides commanders with flexible response options. Russia's bomber fleet reflects a fundamentally different strategic philosophy than American approaches. Where the United States prioritizes stealth and precision, Russia emphasizes overwhelming firepower and operational flexibility. These competing philosophies create distinct advantages and vulnerabilities that define contemporary strategic competition. Moscow's commitment to maintaining three distinct bomber types ensures Russian forces can adapt to various threat environments and mission requirements, much like America's multi-platform approach. Yet these proven giants face obsolescence against tomorrow's invisible threats. Three nations now race to deploy stealth bombers so advanced they could render traditional air defenses completely useless. The next decade will determine which superpower controls the skies through invisibility rather than firepower. America's B-21 Raider leads this technological revolution with capabilities that extend far beyond simple radar evasion. Northrop Grumman designed this flying wing to operate in both manned and unmanned configurations, transforming the aircraft from a traditional bomber into an autonomous weapons platform. Remote pilots could direct missions from thousands of miles away, eliminating human risk while maintaining precise control over nuclear and conventional strikes. The Raider's modular design allows rapid reconfiguration for different mission types. Intelligence-gathering sensors replace weapons bays for reconnaissance missions. Electronic warfare equipment transforms the bomber into a flying jamming station. Air-to-air missiles convert the platform into a long-range interceptor. This flexibility ensures the B-21 remains relevant across multiple combat scenarios that future conflicts might demand. Advanced stealth coatings cover every surface of the aircraft, incorporating materials that absorb electromagnetic energy across broader frequency ranges than previous generations achieved. The B-21's signature management extends beyond radar invisibility to include infrared suppression, acoustic dampening, and visual camouflage systems that make detection extremely difficult regardless of the sensor type employed. 100 B-21 Raiders will enter service during the next decade, each costing $639 million to build. This fleet represents America's commitment to maintaining strategic superiority through technological advancement rather than numerical advantage. China's H-20 stealth bomber challenges American dominance through a dramatically different approach. Beijing developed this flying wing design independently, rejecting Russian bomber philosophies in favor of stealth-first engineering that mirrors successful American programs. Computer-generated imagery reveals weapons bays, radar-absorbent materials, and aerodynamic shaping that closely parallels the B-2 Spirit's revolutionary design. The H-20 carries 4 hypersonic cruise missiles internally, maintaining stealth characteristics while delivering weapons that travel at speeds exceeding Mach 5. These missiles extend the bomber's effective range to intercontinental distances, allowing strikes against targets anywhere on Earth without the aircraft leaving Chinese airspace. This standoff capability transforms regional Chinese bombers into global strategic weapons. Development timelines suggest the H-20 could achieve initial operational capability within 5 years, making China the second nation to field advanced stealth bombers. This timeline pressures American planners who assumed decades would pass before credible stealth competition emerged from rival powers. Russia's PAKDA project pursues stealth through subsonic efficiency rather than supersonic penetration. The Tupolev Design Bureau abandoned the Tu-160 speed-focused approach in favor of long-range invisibility that matches American strategic thinking. 7,000 miles of unrefueled range combined with advanced stealth technology creates a bomber capable of striking targets globally while avoiding detection. The PAKDA's flying wing configuration represents a fundamental shift in Russian bomber design philosophy. Previous Soviet and Russian bombers emphasized speed, payload, and defensive armament over stealth characteristics. The PAKDA prioritizes invisibility above all other capabilities, acknowledging that modern air defense systems make traditional penetration methods obsolete. 3 prototypes begin testing in 2023, with production starting in 2027 at an estimated cost of $400 million per aircraft. Russia plans to replace both Tu-95 and Tu-160 fleets with this single stealth platform, simplifying logistics while maximizing technological advancement. These next-generation bombers share common characteristics that define future strategic warfare. Stealth technology becomes the primary survival mechanism. Long-range standoff weapons eliminate the need for close target approaches. Autonomous systems reduce crew requirements and political risks. Modular designs enable rapid mission reconfiguration. The nation that successfully deploys these invisible weapons first gains decisive advantages in any future conflict. Traditional air defenses become worthless against aircraft that remain undetected until their weapons detonate. The strategic balance shifts toward powers that master stealth technology rather than those that simply accumulate conventional firepower. America's current lead in stealth bomber technology faces serious challenges from determined competitors who learned valuable lessons from observing B-2 operations over 3 decades of service. While America and Russia perfect their invisible giants, another superpower emerges. What happens when the world's most populous nation decides to master the art of long-range destruction? China's transformation from a regional military power to a global strategic force has been nothing short of remarkable, and nowhere is this evolution more evident than in its bomber program. For decades, the People's Liberation Army Air Force relied on outdated Soviet designs and limited-range aircraft. Today, China stands on the brink of deploying bombers that can strike targets anywhere in the Pacific and beyond. The foundation of China's bomber revolution began with the H-6 series, originally based on the Soviet Tu-16 design from the 1950s. But calling modern Chinese bombers mere copies would be gravely mistaken. The H-6K variant represents a complete modernization of the original concept, featuring advanced radar systems, precision-guided munitions, and significantly extended range capabilities. This upgraded bomber can carry up to 86,000 pounds of weapons across distances that would have been impossible for earlier versions. The H-6K's most significant improvement lies in its ability to launch long-range cruise missiles, transforming it from a traditional bomber into a standoff strike platform. Chinese engineers have essentially taken a Cold War relic and turned it into a 21st century weapon system. Even more impressive is the H-6N variant, which takes the concept of aerial refueling to new heights. This aircraft can carry and deploy air-launched ballistic missiles, including the formidable DF-21 anti-ship missile. The strategic implications are staggering. China now possesses the ability to target aircraft carriers and naval formations from distances well beyond the reach of defensive systems. The H-6N's aerial refueling capabilities extend its operational range to cover the entire first island chain and beyond. This means Chinese bombers can now reach targets in Japan, the Philippines, and even approach the second island chain that includes Guam. For the first time in modern history, China possesses genuine long-range strike capabilities that rival those of established military powers. But China's true bomber revolution lies in the development of the H-20 stealth bomber, a project shrouded in secrecy yet impossible to ignore. Intelligence reports and satellite imagery suggest this aircraft will be China's first indigenous stealth bomber, featuring a flying wing design remarkably similar to American concepts. The H-20 represents far more than technological advancement. It signals China's intention to project power globally rather than merely defend its regional interests. Early estimates suggest this stealth bomber will have an operational range of at least 5,000 miles, capable of reaching targets across the Pacific without refueling. What makes the H-20 particularly concerning for rival nations is its potential payload capacity. Analysis suggests it could carry up to 4 hypersonic cruise missiles while maintaining its stealth profile. This combination of invisibility and cutting-edge weaponry would give China the ability to conduct surprise strikes against high-value targets anywhere in the Asia-Pacific region. The technological leap from the original H-6 to the H-20 illustrates China's remarkable progress in military aviation. In less than 2 decades, Chinese engineers have advanced from reverse engineering Soviet designs to developing indigenous stealth technology that rivals the most advanced Western systems. China's bomber modernization reflects broader strategic shifts in global power dynamics. As tensions rise in the South China Sea and Taiwan Strait, the ability to project force across vast distances becomes increasingly important. The H-20 bomber will provide China with what military analysts call anti-access area denial capabilities, essentially the power to keep rival forces away from Chinese interests. The economic implications of China's bomber program are equally significant. The massive investment in advanced aviation technology demonstrates Beijing's commitment to military modernization, regardless of cost. This sustained funding has allowed Chinese defense contractors to develop capabilities that many experts thought would take decades to achieve. Perhaps most importantly, China's bomber revolution changes the strategic calculus for every nation in the Pacific region. The emergence of a third major power with genuine long-range strike capabilities creates a multipolar world where no single nation can assume air superiority. China's rise as a strategic bomber power represents a fundamental shift in global military balance, one that will shape international relations for decades to come. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.